Hello, this is Ted Phillips, Solution Architect with Advantech. Since we're not able to do on-site training for a while, I'll be shooting some YouTube videos to help you get started with our IoT products. Today we're talking about IoT and MQTT. IoT and SCADA have many overlapping functions, but basically SCADA, supervisory control and data acquisition, is used to control machines and connect PLCs to systems that run the machines in the plant. Where IIoT is used as a monitoring function, where you're looking to maximize efficiency, reduce unplanned downtime, comply with reporting regulations, and visualize project flow. So they're two kind of different things. And the protocols that you use for SCADA and IoT are different as well. SCADA normally uses client-server communication such as Modbus, Profinet, EtherCAT, something like that. Where IIoT uses something a little more efficient, which is a publish-subscribe protocol such as MQTT. Client-server systems have to be really fast so you can actually control the machine, so they're going to connect directly to a server, authenticate with correct credentials and the information, the HMIs or whatever you're using is going to ask for that information. The server is going to reply with the data. The client will acknowledge the data, and the client disconnects from the server. So there's a lot of going back and forth, and it's a heavyweight protocol. Where with MQTT, it's a much lighter weight protocol. MQTT stands for Message Queuing and Telemetry Transport. It was invented by Arlen Nipper and Andy Stanford Clark back in 1999 when they were working in Europe in the oil fields and trying to get their information back to a home base through a satellite communication system. It's an open standard hosted by Oasis. It's an ISO standard, lightweight, publish-subscribe protocol. It transfers messages between devices and a broker. Usually runs over TCP/IP. However, it'll actually work over pretty much any kind of network that can support a lossless bidirectional connection. Since it's a publish-subscribe protocol, it uses a broker. These are kind of the things that we need to pay attention to. And the devices at the edge, they're going to know topics, valuable information, a schedule, and exceptions. So we'll talk about what this means in just a second. A lot of it is very much like the way that Twitter works, if you're familiar with Twitter, where someone has valuable information, they assign a hashtag to it, and then they tweet it out to a broker, which is a Twitter server. And then the server actually forwards that out to the subscribers or followers, the people who follow that particular hashtag. Some people send messages on a schedule every Sunday or every Tuesday or whatever. Others just tweet something out when something interesting happens or by exception. Pretty much the same way with the IoT device, where it's got valuable information, which is the sensor data. The device publishes it to a broker on a schedule under its topic. Some devices will also publish when something out of the ordinary happens or by exception. The broker then forwards that valuable information, the sensor data, to other devices that have subscribed to its topic. And those other devices may be databases, they may be report generators, they may be alert or alarm devices that send out text messages or emails, or they may be dashboards where you can pull it up on a monitor, on HMI, or your phone to see what's going on in the system. Valuable information is identified by a topic. And per the MQTT standard, the topic can be pretty much anything. But in order to be useful in an IoT system, you want to have that topic identify the devices generating the information as well as tell you what the information is. An example of an Advantech wizard topic is BB / the serial number of the device / CFG. This means the device was manufactured by Advantech B&B. It's got a unique identifier, which is the MAC address, and the information contained in this topic is configuration data. The actual information, the valuable information, is referred to as a payload. And the payload in MQTT can be almost anything, but most IoT devices format it as a JSON string or key value pairs. The benefits of MQTT are the data packets are small and lightweight. All devices connect to a broker, so there's no direct connection between device originating the data and a device consuming the data. The broker is the only component that needs a routable address, so you don't have cellular routers that need public static addresses, and you don't have to worry about things being insecure or firewalls or anything like that. The data becomes a resource on the broker that anyone can use. It's authorized, so it's not a direct connection between a sensor and a controller or something like that. Multiple clients can connect on any topic. The broker can also track the state of the sensor nodes via a birth certificate and a last will statement. The birth certificate will tell the broker that the device is online, and sometimes will actually explain what the resources are available on that device. And we'll talk about that a little bit later. The death certificate is something that the device tells the broker. It says, if you don't hear from me in a certain period of time, tell everybody what happened. And so sometimes that's as simple as just online for a birth certificate and offline for the last will. Otherwise, it may be, for the birth certificate, it may actually explain all of the capability of the device. Some MQTT devices also track the health of the broker, so if the broker goes down, they can look for an alternate broker. Advanced devices, as I said up above, describe themselves as well as all of their topics. So smart MQTT clients like Advantech Edge and Inductive Automation Ignition can auto-configure tags based on the information in the birth certificate. Now we'll do a little hands-on exercise in order to understand how simple it is to use a MQTT. We're going to just send some random messages back and forth and see how that works. And we're going to use an open source program called MQTT-FX to do that. So let's take a look at MQTT-FX. And this is what it looks like. And what we'll do is click on this little gear up here. And what this will allow us to do is define a broker that we're going to use. And just for the test, we're going to use a public broker that's out in the internet at HiveMQ. So we'll give it a name, test server or something like that. And we're going to give it the address, which is broker.hivemq.com. And we're going to give it a client ID, and it doesn't really matter what that is, but we can just type something in there. And that's pretty much all we need. So let's click OK and see if we can connect to that server. And it shows that we're connected. So now what we're going to do is we're going to actually subscribe to a topic on that server. So very much like Twitter, we're going to follow a message. And what we're going to do is we're going to follow Advantech/training/#. And what that is a topic that starts with the name Advantech, has the name training, and then the # can mean anything after that. It's called a wildcard. So we're going to subscribe to that topic. And now we're going to go and we're going to publish something. And we're going to actually publish to a topic called Advantech/training/TED. So let's type in here hello YouTube visitors. Okay, and we're going to publish this message out. And now let's look and see that we've subscribed, and we see that the message came through. It shows that we've subscribed to Advantech Training. The message actually came from Advantech Training TED, and the message that we're seeing is hello YouTube videos. So that's how we can send plain text over MQTT. So now let's actually connect to a live server so that we can see some real MQTT data and see that JSON format that I talked about a little earlier. So we'll just connect to this and we'll connect to a live server. And on that server, we're going to subscribe to BB/#, which is anything that was made by Advantech BB. And we're going to subscribe there. And right away, we start getting a whole bunch of information. So if we look at these messages, this message is actually coming in JSON. So we have key value pairs, VBAT, and it tells us what the battery voltage is, temp int, what the temperature is, temp1, and temperature. So these are all messages that are actually coming in from IoT devices. and we can see, the key name, the value name, and the unique identifier of those devices. So that's kind of it. We've actually looked at MQTT, looked at some of the advantages of it, and looked at how we can send straight text messages over MQTT, and also how we can look at information coming from devices. In our next video, we're going to look at actually how to use that information coming in on the MQTT to generate a dashboard so we can visualize input from an IoT device. Thank you very much for watching.